In the past few videos, we investigated how homotopy type theory is applied to logic. But in this video, we are going to return to the start of our journey. We are going to investigate path induction. Recall that we can think of a type as a space, and we can think of the terms in that type as points in that space. In this case, an inhabitant of the equality type x equals y corresponds to a path from x to y. Let's consider the equality type x equals x. In homotopy type theory, we can always construct a special path from a term to itself. In this case, we will call this path ref x. But here's where the magic happens. According to the principle of path induction, whenever we need to prove that something is true for a path from x to y, we only need to prove that it is true for the path ref x from x to x. Let's take a look at an example. Suppose we did have a path P demonstrating that x is equal to y. How do we then show that there's a path P inverse from y to x? Let's express this as a function type. We want to construct a function that, given the terms x and y in A, returns a function that maps a term in x equals y to a term in y equals x. Let's call this function sim, since it proves that equalities are symmetrical. According to the path induction principle, we need only consider the case where y is definitionally equal to x, and the path from x to x is ref x. In that case, we simply need to define sim of x ref x as being equal to ref x. Applying the path induction principle, we now know that since the path ref x from x to x has an inverse, any path P from x to y also has an inverse. Therefore, we have just proven that equalities are symmetrical. Thanks for watching.